So for our statics assignment, we selected a topic that comes from our everyday life, which is this signboard right here with a plastic bag of drinking water hung at this side. Have you ever wondered how this signboard just doesn't drop on you when you walk under it? And how it just stands right there without falling? This is because of statics. Static is a state of linear and angular equilibrium. It means that when an object is in statics, its total vertical force Fy is equal to 0, the total horizontal force Fx is equal to 0, and the total momentum at any point m is also equals to 0. By using this signboard, we are going to demonstrate you 3 statics learning outcomes.
Now for learning outcome number 1, we are to analyze systems using free body diagram methods. Now how to draw free body diagrams. First, you must identify the body or the object of which you want to draw the free body diagram. Next, we draw the main body with the exact measurements from the object itself. And then we have to draw the forces that are connected towards that are acted towards the body. All the forces, including weight, friction, reactionary force, anything. And then we have to label the forces with the magnitudes. Now for our bus stop, first we must draw the free body diagram here. As you can see, that's the first step. The second step, the bus stop sign. And the second step is to fill it with measurements. There we go, the exact measurements. And then we must draw the forces by identify the forces and draw them using arrows. And we have the force from the back of AO and the weight of the bus stop sign itself.
So after we draw the free body diagram, we can start our calculation. So since this is in equilibrium, so first the summation of force in y-axis equal to 0. So the force R is acting upwards, and this one is weight, and WB and WP is acting downwards. So R equals to all those forces. So R equals to 17.66 plus 2WB plus WP. So next one, the summation of force in x-axis equals to 0. So mu R is acting towards right, while the other forces omega WB plus G and omega WB is acting towards left. So mu R equals to these two forces. Okay.
And now moving to the moment, since the whole system is in equilibrium, the moment at any point is equals to 0. Now we choose point B, and then at point B, the force for this force is acting towards the left, and then we can see it has a 90-degree angle to the point B, and it's turning anti-clockwise, so the symbol is plus here. And then it's same goes to the force here, and then so is anti-clockwise too, and then so is the plus symbol. And then the 2 is the distance from this force to B, and 1.4 is the distance from this force to B. For the 2WB downwards and also the 9.81 newtons downwards, both of the force is 0.4 from point B. This was going downwards, and the 90 degrees here. From the force we move to the point B is in clockwise direction. That's why the symbol here, and also for this is also negative. And after we rearrange this equation, we'll get WB equals to 1.584 Newton. Oh, for your information, the omega here is equal to 0.6 according to what we search from the internet. And then after we get the value for WB, we substitute this equation into equation 2. Then we'll get R equals to 25.96 Newton. After we get R, substitute R into equation 1 and we'll get the value for WP, which is 5.128.
Hello, I am Fatwa Media, KIB1003. I want to tell you about learning outcome 3, moment of inertia. First, I want to tell you about the introduction. What is inertia? The inertia of an object is the tendency of the object to remain at rest or if moving, to continue its motion. Then the methodology that I use to calculate the inertia respect to the axis is this 6 formula. This is to calculate the inertia. This is to calculate the radius of gyration. Then the LO3. What is the learning outcome 3 that I want to explain to you? The learning outcome 3 is to employ moment and inertia based analysis for problem solving. The objective that I want to achieve is search inertia respect to x-axis and y-axis from the things that we choose to calculate it, and then search the radius of gyration both x-axis and also y-axis. And then this is the free body diagram from the thing that we choose to calculate, and this is the free body diagram that I make it simple. And then I divide it into 4 parts. This is the first part. This is the first part. This is the second part. This is the third part, and this is the last part. So this is the calculation that I already calculated to search the to make easier to calculate the inertia. This is why the dy is 0 while the others have the distance of y, because I gonna use the moment of inertia without parallel axis theorem, because this already in the edge of the axis. So let's to calculate the inertia. For the first part, I just use 1/3 dh3 because the part is already in the edge of the axis. And then while others, I use 1/12 bh3 plus a dy square, because I use parallel axis theorem. Why? Because all of these 3 parts is not in the edge of the axis, is some in the middle of axis. There is a distance between the part and also the axis, so we use the parallel axis theorem. This is the Ix total that I already calculated. And then we search the radius of gyration respect to x-axis. This is the radius of gyration respect to x-axis. And then respect to y-axis, I use again 0 in the distance of x, y, because the path is already in the edge of the axis. So I gonna use 1/3 b3h b cubic h, because the path is already in the edge of the axis. I do not use parallel axis theorem anymore. Instead of these 3, I use parallel axis theorem. This is the Iy total inertia respect to y axis total. Is Iy inertia y part 1 plus part 2 plus part 3 and then plus part 4. And then I calculate the radius of gyration is radical inertia y total divided by A1 area part 1 plus area part 2 plus area part 3 plus area part 4. This is the calculation of radius of gyration respect to y axis.